Hey everybody, this is Mr. Ainsworth, and we're going to get into a Geometry B review. That means second semester geometry here. Going over a ton of problems, so there's like over 60, so we'll probably do this in multiple parts. All right, get your red pen out and your pencil, calculator off to the side. I've got mine, I've got my TA84 here. So you get yours ready to rock, and let's get started. Remember, this is a video, right? So if I go too fast, you pause, play, and rewind and figure things out. All right, and it's one thing watching me, it's another thing doing it by yourself. So make sure you keep that in mind. All right, if you can't do it, then practice it multiple times until you can do it by yourself. Okay, now when it comes to proportions here, guys, what we want to do is cross multiply. Okay, that's probably the easiest way to handle this. So cross multiply is our technique. And what we want to do is take a look at the cross products here and here. Okay, so what do we have? We have 12 times y is equal to 5 times the quantity 2y minus 6. You want to distribute through the 5. So we have 12y is equal to 10y minus 30. Collect like terms, so subtract 10y. And I get 2y is equal to negative 30. 2 times negative 15 is negative 30, so y has to be negative 15. And if you don't see that, divide by 2, and you'll see that y is equal to negative 15. Okay? So cross multiply is the technique. On number 2, the triangles are similar, and because of that, corresponding angles are congruent. All right? And usually these congruent symbols are not given here. So keep that in mind. I know that R corresponds to U. I can see that right here, and that means they're congruent. So this is 47 degrees here. I know that Q is congruent to T, so this is 63 degrees over here. I want to find angle V, this one right here. So what we do know is that the sum of all three angles always sums to 180. Okay, that's called the Triangle Sum Theorem. All right, three angles sum to 180. So what you do is you add up the two knowns. Okay, 63, 47, that's 110. All right, and then 180 minus 110, well, that's 70, right? So the measure of angle V is 70 degrees. No problem. Piece of cake. Okay, number 3, explain why the triangles are similar. Well, then find the value of x. Okay, they're similar because I see a pair of congruent angles here, and I see another pair here. So because we have two pairs of angles, they're similar by angle-angle similarity. So triangles are similar, all right, by angle-angle similarity because they've got two pairs, all right, of congruent angles. Because of that, I use angle-angle similarity to get them similar, and because of that, that tells me that ratios of corresponding sides are proportional. So ratios of corresponding size are proportional, and that means they are equal. All right, so what we do is I'm going to go big to small, so 20 to 3. So 20 to 3 is proportional to 15 to x. All right, cross multiply. So I've got 20x is equal to 45. Remember what cross multiply means. I have to multiply those two, and I have to set equal to these two, all right? And then divide by 20. Okay, x is equal to 45 20ths, which means that it's, let me see, 20 divides into 45 2 times the 5 remaining. So 2 and 5 20ths. That's 2 and 1/4. So x is 2 1/4, or if you left it as an improper fraction, it'd be 9/4. All right, next one, number 4. We got shadow problem. So we got a 4.5-foot mailbox post cast 6-foot shadow. So here's the ground. Here's the mailbox right here. Mailbox, whatever. Okay, it's 4.5 feet high, so 4.5 feet, 6-foot shadow. The sun's over here. Okay. Okay, here's the shadow length. How long is it? Read the problem. 6-foot shadow, right? So this is 6 feet. A nearby flagpole, it's a taller one, right? Right there, flagpole casts a 20-foot shadow. Now the sun does the same thing, it casts a shadow, right? So that's not the, well drawn, let's see. There we go. So here's the shadow of the flagpole. And now it's 20 feet here. What's the height? How tall? How tall? H. How tall is the light pole or the flagpole? Let me make it look like a flag. There we go. Flag. Let me make it a little bit better. There we go. Flagpole. Okay, so this is a similarity problem. Triangles are similar, so the ratios of corresponding sides are the same. So let's go height to height, right? So 4.5 to h, shadow to shadow, 6 to 20. Cross multiply again. Cross multiply right here and here. And you got 6 times h, 6h is equal to 4.5 times 20. 2 times 4.5 is 9, times 10, that's 90. If you don't know that, then use your calculator. Watch this. 4.5 times 20, it better be 90. Okay, so you have 6h equals 90, divide by 6. Use your calculator again, make it simple. Divide by 6, piece of cake, 15. So h is 15 feet. All right, and we're talking about the flagpole. There we go. That's how you do the first 4 problems. Now let's do a few more, okay? This is all chapter 7, by the way. All right, chapter 7 on similarity. It's going all the way back to the beginning of the semester. Here's another similarity problem here. They're similar. Give a complete similarity statement, give the reason for similarity, or explain why they're not. Okay, so first of all, I've got a little triangle, this one right here, inside a bigger one, okay, SQR. So UQV, let's see if it's similar to SQR, okay, small to big. So again, we've got a small one and then a bigger one. So let's get some side lengths. Okay, now 45 minus 18, that's 27, so this is length 27. I know that 40 take away 16 is 24, so this is 24. So I get my sides. Okay, so hypotenuse to hypotenuse. So I want to take this ratio right here. So 27 to 45, 27 to 45. Is that equal or proportional to 24? Look at this, 24 to 40. Okay, VQ to RQ, base to base. So 24 to 40. I don't know. Let's simplify. So, or check cross products, one of the two. Either simplify or check cross products. So these are both divisible by 9, so 3/5 here. These are both divisible by 8, so I get 3/5. Divide both of these by 8 and you get 3/5. They're equal, right? And they also have a common angle. All right, so that's a side angle side similarity. So the triangles are similar, all right, by side angle side similarity because these are proportional. All right, so triangle QRS, let me see, QRS, that's the big one, is similar to the small one, QVU. Triangle QVU, that's the small one in red. There we go. By, all right, side angle side similarity. I got the sides ratios of corresponding sides are proportional, and they have that common angle in between them. That's where this angle comes from. It's in between the two sides that are given, side angle side. Okay. Next one, number 6. Solve for the missing side. This is a Pythagorean theorem problem because of the right angle right here. So it's our famous Pythagorean theorem, which goes leg squared plus leg squared is equal to hypotenuse squared. This is a leg. We got a leg. We got a hypotenuse. Call it C right now. So we take 5 squared plus 8 squared is equal to C squared. Gives you 25 plus 64 is equal to C squared. That's 89 equals C squared. And you have to take the square root. And you get the square root of 89 is equal to C. And you're done. It's that simple. Same thing here. You got a leg here, and you got a leg here, and you got a hypotenuse here. Okay, so let's call this x. So we got x squared plus 9 squared is equal to hypotenuse. Always end with a hypotenuse squared. So you get x squared plus 81 equals 256. If you didn't know that, just type in 16 and hit the square button. You get 256. Subtract 81. Use your calculator if you choose to. All right, watch this. Minus 81. I'm just showing you how to use the technology. 175. Square root. So you get the square root of 175, but that needs to be simplified. So let's take 175 over here, divided by 5. If you don't know what that is, just go divided by 5, and you get 35. Divided by 5, you get 7. Divided by 7, you get 1. So my factors are 7 and 25. 7 times 25 is 175. So the square root of 25 times the square root of 7 gives you 5 rad 7. Okay, not negative, not plus or minus, because this leg can't be negative. Distance is always positive. That's the way it goes. Okay, there's the first 7. All right, next one. Find the exact length of the hypotenuse. Well, first of all, to go from leg to hypotenuse on a 45, 45, 90, you simply have to multiply by rad 2. So 3 rad 2 times rad 2 is 3 rad 4, which is 3 times 2, or 6. So my hypotenuse is 6. The other leg, since it's isosceles, is 3 rad 2. Okay, same thing here, but the other direction. To go from hypotenuse back to the leg, all right, you have to divide by rad 2. So 22 divided by rad 2 needs to be rationalized, so let's rationalize. Always use the denominator. All right, and you get 22 rad 2 divided by rad 4, which is 22 rad 2 divided by 2. Simplify the fraction here. 22 divided by 2 is 11, and it gives you 11 rad 2. So this is 11 rad 2 here, and this is 11 rad 2 here. Remember, it's isosceles. All right. Now, in the 30, 60, 90, this is the 60 degrees here. This is called a 30, 60, 90. The relationships are different, okay? The side opposite of the 30-degree angle is the shorter side. All right? It's always half the hypotenuse, which means you got to double to get the hypotenuse, which means that y has got to be 16 times 2, or 32. So it's 32 units here. Go from short to the medium length side. Well, it's getting longer, so you got to multiply, but this time rad 3. So x is equal to 16 times rad 3. All right. Now on this one, find the length of the leg. We're not given any angles here, so we're gonna have to make an assumption. Oh, some of the important information needs to be put in. Let's say it's an isosceles right triangle. So it's an isosceles right triangle. So if that's the case, then these are both 45 degrees here and here. All right, and if that's the case, we're going to divide by rad 2 to get to the leg, just like we did on previous problem. So 7 divided by rad 2, you got to rationalize it. And you get 7 rad 2 divided by rad 4, which is just 2. So x equals 7 rad 2 over 2, and they're both 7 rad 2 over 2. Okay? 7 root 2 divided by 2. All right, number 12. We got a similarity problem again. A lot of chapter 7 here. So that tells me that ratios, okay, of corresponding sides are proportional. Are proportional. What does that mean? Well, it means they're equal. All right, so you take the scale factor, or the similarity ratio of 1 to 3. This is a small to big ratio, obviously. So 1 to 3 is proportional to the ratio of corresponding sides, which is x minus 5 to 12. All right, cross multiply. 12 times 1 is 12. And you got 3 times the quantity x minus 5. You can either distribute or divide by 3, one of the two. Most people distribute. Add 15. And you get 27 equals 3x, so x has to be 9. Okay, now if x is 9, then 9 minus 5 is 4, so this length is 4. 1 to 3 ratio means that the other side is 3 times as large, and 12 is 3 times as big as 4, so that this answer makes sense. Okay, number 13. Okay, we got a new ramp. Owner is planning to install a new ramp on a loading dock. The ramp must make an angle 10 degrees with the ground. So if you want to draw a simple little picture here, here's the ground, here's the height, there's the ramp. Okay, and the angle with the ground is 10 degrees, and this is the ramp. The loading dock is 3 feet above the ground, 3 feet. How long must the ramp be? Boom. Okay, how long must the ramp be, and how far away is it from the base of the dock to extend it? How far away from the base of the dock must it extend? Okay, that's y. So this is right. How long does the ramp have to be? That's x. And then the second part here, how far away from the base? Well, we'll call that y. So we got to do actually two of them here, and this takes a little trig. So Sohcahtoa. All right, Sohcahtoa. So on this one here, what we're going to do is we're going to take we're going to label first. So this is the opposite side, this is the adjacent side, and this hypotenuse. Okay, so what we have is that the opposite in hypotenuse is a sine function. So the sine of 10 degrees is equal to 3 divided by x. Okay, probably the easiest way to handle this is to make it look like a proportion and cross multiply. Probably the easiest way. So if you cross multiply, you get x times the sine of 10 degrees is equal to 3 divided by the sine of 10 degrees on both sides. And you get x is equal to 3 divided by the sine of 10 degrees. Kick in your scientific calculator. So clear, 3. Let me just check something, the mode here. It's got to be in degree mode. Okay. Okay, so I enter in 3, hit divided by, sine 10 degrees, boom. Let the calculator do the work. 17.3. So it's approximately 17.3 feet. They're all in feet. That's the first answer. Now the second one, got to keep on working here. I got to find y, so that's opposite divided by adjacent. That's a tangent function. See, opposite divided by adjacent. So the tangent of 10 degrees is equal to 3 divided by y. So cross multiply again and make it look like a fraction. So you get y times the tangent of degrees is equal to 3 divided by the tangent of 10 degrees. And you get y is equal to 3 divided by the tangent of 10 degrees this time. Another calculator problem. It's a different value, right? So it's going to be less than this because the hypotenuse is always longer than the other sides. So you take 3 divided by the tangent of 10 degrees and see what happens. 17, roughly. So y is approximately 17 feet from the base. And that's how it's done, my friends. Okay. Next one. Okay, we actually solved this problem a while back. Okay, how high is the arch? Okay, from here to here. Okay, so it's going to be x plus 5, whatever it is. So h is x plus 5. We got to find x first. Okay, so find x. Ooh, don't say there it is. Okay, we got to find it first. So we got opposite divided by adjacent. So this is the opposite side. This is the adjacent. So this is a tangent function again. So the tangent of my angle, 48 degrees, is equal to x divided by 36. Oh, I got to isolate x, so I got to do the inverse here. I got to multiply by 36 on both sides. So, and then I got to just evaluate it. So check this out. We've got, whoops. There we go. I'm going to clear it out. I've got 36 times the tangent of 48 degrees. It's about 39.98, or roughly 40. So x here is roughly 40 feet, but that's not the height of the arch. The arch is 5 feet higher than that, right? So 40 plus 5, so h is equal to 40 plus 5. H is about 45 feet. And there we go. All right, cruising along. Let's try another one. Solve for the missing sides. Okay, another 30, 60, 90 triangle. Okay, this is, I think, chapter 8. If you guys want to take a look at your notes. We just went through a lot of chapter 7 problems. Now we're in chapter 8. 30, 60, 90. So you got a hypotenuse here. You got the shortest side here. Now, I did a problem similar to this. Now, check this out. Where'd it go? Let me find it here. Where's the 36? Oh, here it is. So from short to hypotenuse, you double. Well, reverse it. You divide by 2 to get back, because the shortest side's a half of the hypotenuse, all right? Or the hypotenuse is 2 times the short side. Think of it either way. So when you think of it that way, you gotta divide, all right? Short is equal to 1/2 the height, all right? The hypotenuse. So you gotta divide by 2. That's easy. So y is equal to 18 rad 3 divided by 2, which is 9 rad 3. So I'm going to put a 9 rad 3 here. And then I got to multiply by rad 3 to get to the medium length side. All right. So x here is, let me see, x is equal to 9 root 3 times root 3, which is 9 times root 9, or 9 times 3, or 27. So x is 27. Okay, and then after you know your 3 sides, then you just use a little bit of Sohcahtoa, right? Because we know what that means. These are just ratios now. So sine of 30 degrees is opposite, all right, divided by hypotenuse. So 9 root 3 over 18 root 3. So 9 root 3 divided by 18 root 3. The root 3's cancel. 9/18 is 1/2. Sine of 60 degrees, that's opposite side divided by hypotenuse. So let me see, this is 27 right here. So 27 divided by 18 root 3. So 27 divided by 18 root 3. I'm going to simplify a little bit, divide both by 9, so I get 3 divided by 2 rad 3, then rationalize. All right, and you get 3 root 3 over 2 times 3, or 6. So 3 root 3 divided by 2, this is 3, right? Root 9 is 3, 2 times 3 is 6. Simplify again, get root 3 over 2. So my final answer is root 3 over 2. And then tangent of 30 degrees is opposite divided by adjacent. So opposite divided by adjacent right here. I take 9 root 3 divided by 27. So 9 root 3 divided by 27. Simplify, you get root 3 over 3. If you don't know why, then divide both by 9. And I get this right here. You can see it, root 3 over 3. So you just have to understand the ratios. Okay, next one here, number 16. Isosceles right triangle with a hypotenuse of 8. So you draw a isosceles right. Isosceles means that the two angles are congruent in a right triangle. That means you got a 45, 45, 90. Hypotenuse is 8, because it tells me that. Find the length of the leg. Well, I just divided by rad 2. I already did this on a previous problem, back up here. But I went from hypotenuse to leg. Yeah, I divided by root 2. I just showed you that, and we simplified it. So it's the same kind of problem. So x must be equal to 8 divided by root 2. Then after you rationalize, you get a root 2 over root 4, which is 2. Simplify, and then x equals 4 rad 2. So they're both 4 rad 2. Why? Because it's isosceles, right? Two congruent sides. That's what isosceles means. Okay, on this one here, now again, Sohcahtoa problem here, because you got trig function here. There we go. Let me see. So the sine of x equals 4/5 is opposite. All right. Oops. Sorry. Opposite divided by hypotenuse. Okay, Sohcahtoa. So opposite of x is got to be 4, hypotenuse is 5. That's what this ratio means. All right, find the tangent and cosine. Well, you got to find the other side to do that. So let's call this side, let's call it a little a, right? Okay, so we got a squared plus 4 squared is equal to 5 squared. A squared plus 16 is equal to 25. That means a squared is equal to 9. That means a is 3. So that's 3 now. Now we know all 3 sides. So the tangent function, okay, that's opposite divided by adjacent. So that's going to be equal to opposite of x, 4, divided by adjacent, 3. So 4/3 cosine would be adjacent divided by hypotenuse, or 3/5. Just by knowing this, just by knowing Sohcahtoa right here, that helps me solve all kinds of problems. Okay, number 18. Moving along here. So what do we have? We have, we're gonna have to make some assumptions here. We're gonna make some assumption that these are actually diameters, and like BD here and CF, we have to make that assumption. Otherwise, you wouldn't be able to solve it. So we have to make assumption that B, A, and D are collinear, and F, A, and C are collinear in order to solve this. So I see vertical angles here. So vertical angles are congruent. You guys should know that. So if that's 50, that's 50. So that's angle BAF. I'm trying to find angle DAF though. So DAF. Ooh, that means I got to find this angle here. Well, let me see. I got a 90-degree angle here. I know that half a circle is obviously 180 degrees. So all three of these angles add up to 180. 90 and 50, so 90 and 50 obviously sums to 140. So 180 minus 140 is 40. So this angle here in the middle is 40 degrees. So angle DAF, DAF. So here it is right here, D to A to F, this one. So it's 40 plus 90, or 130 degrees. Okay, FCB. Arc FCB. So arc FCB. So F through C all the way to B. So you start here and go all the way here. Okay, let's do it the easy way here. So this is 50-degree arc, but I want F all the way around. No, through C. No, all the way to B. Right there. That's a big arc, right? Well, it's 360 minus the 50, so it's 310. So this is 310 degrees. Arc starts at F. This is an arc now, okay? So it goes through C and ends at B. Start and finish, okay? Start at F, go through C, end at B. That's almost all the way around, but not quite. And 50 degrees short, so it's just subtracted from 360. All right, let's do a few more, because there's a lot of problems in this review. Let me see, let me see, 19. I'll tell you what, we're going to pause here. This is going to be part 2, okay? So if you need from 19 on for the next 20 problems, go back to my website and go into part 2, okay? So we're going to break this up into parts. This is part 1, first few problems here. Part number 1, and I'll probably break this up into 3 parts. So it'd be easy to take a look at. Otherwise, the videos are going to be so long. Okay? So I will see you in my next video if you need it. All right, this is Mr. Ainsworth. Bye-bye now.